What's going on, everybody? Zane here, back with another video. For this one, we've got question number 23, which is merge k sorted lists. So we're given an array of k linked lists, and it's called lists. And each linked list is sorted in an ascending order. Our task is to return, another list, but we're taking all of those lists and sorting them and returning it as one. I just said that's so weird. Our task is to take all of the linked lists and then return it as one list in ascending order. So if you take a look at this example here, and bear with me, this is more of a journal entry for myself, and hopefully I can help out someone along the way. But our input is going to be a list of lists, and each of these lists is in ascending order, and we need to essentially extract these lists and return it as one list, and all numbers have to be in ascending order. So when taking a look at the approach for this, I saw that there was a brute force method of going through all of the lists and storing them into an array, and then sorting it after we've sorted in an array. Now, considering that breaking these down would require us to iterate through all of the values, that would be O of n time, and then sorting it would be log of n time. So the entire time space complexity would most likely be O of n times O of log of n, which isn't necessarily the most optimized approach. So digging a little bit deeper, I found that there was the merge sort or divide and conquer approach, where we'll essentially have a start and end point, and we'll consistently divide this list of lists into two lists. So this right here that I'm highlighting would be our list one, and then the other one here would be our second list, or list node, or whatever you want to call it right now. And then we'll keep doing that until we get to a point where we'll recursively call some function that will keep dividing our lists of lists until we reach our base case, which would most likely be where our indexes are the same, meaning there's only one list. So let's just dive into the code here. We're given a list node array called lists, and we need to return a list node. So right off the bat, we need to get our base case out of the way. And that's going to be if list is null, or the length of the list is 0, then we just return null. Otherwise, now we can recursively call some function that will return to our base case at some point once all of the other calculations are done. So now we can do our recursive call. And I'm going to call this divide and conquer. I'm going to copy that. Otherwise, we're just going to return the recursive call of our divide and conquer helper function, and that's going to be taking in our lists. And like we mentioned, we're going to have a divide and conquer approach, which is going to require a start and an end point. So in this case, I'm going to just start it at 0 because this is our first call, and we're going to end it at the end of the list length, or in this case, it would be just list.length -1. So it'll recursively call this until we get to a point where the base case is reached. So it's either it'll return null or it'll return whatever the value of this divide and conquer is. Now this helper function is going to return a list node. That's because this is requiring a list node to be returned. So if we go back out here, we'll just define our divide and conquer helper function. And this is going to return a list node. It's going to be called divide and conquer, and it's going to take in these three arguments or parameters. Oops, this is in the wrong spot. So divide and conquer is going to take in a list node array, and we'll call it lists. It's going to take a integer start and an integer end. So now here what we could say is we need another base case. So what we were saying is that this function is going to continuously divide. And we only need it to divide when there's multiple lists, right? So if there were 2 lists, that's fine. If there's 3 lists, that's fine. But what if there was just the one list? that would mean that our start value, which could be like 0, is also the same as our end value because it's the same list, meaning when the start and the end value are the same, that means that we're at our final call or our final iteration of our recursive call. So we could just return lists at start or lists at end. Perhaps just lists at end would work too. Maybe we should try this out later on. But lists at start is going to be what we return. Otherwise, we need to start dividing our lists. So what we'll first want to do is we need to divide it by inclusively retrieving the first few lists and then the end list here. So taking a look back at this example, if we wanted to take the middle, we'll just say that the middle is going to be the start value plus the end value divided by 2. That's just basic arithmetic. We're getting the start and the end, dividing it by 2 to get to the midpoint. Now, once we've gone to the midpoint, that means that we can now divide our list node array into 2 sections, from the middle to the left, from the middle to the right. So what we can do now is we can create 2 separate sides. So we'll say a list node left is going to equal, and now we'll want to take our midpoint and our start and end values and kind of recursively call the same function again. So what we'll do is we'll call this again. We'll pass in our lists. We're starting at the start value and we're ending at the mid value. So we're getting our first bit. So this is our first splicing. So we're getting from the start to the middle right here, let's say. Now we want to get the right side. So we'll say list node right is going to be divide and conquer again. So we're recursively calling the same function. We're passing in lists just as normal. But what would start be? Or what would our start parameter be? It's not going to be start. We already used start and mid, so we've gone from here, start to mid. Now we just need to get to something to the end. And that something is just going to be mid plus 1. And the reason for that is because mid is essentially our index here. And we're trying to be inclusive on our left side and exclusive on our right side when it comes to using the mid variable. So we'll say mid plus 1 to the end of our list node. Now that we've gotten our 2 left and right sides, so we're constantly dividing our left and right, now we can actually do the merging. And for the merging, we're also going to use a helper function. So let me just go down a bit low. So now what I'll do is we can return, and I'm going to make a helper function called merge sort, and return whatever the value of this merge sort is when we pass in our left and right sides. Now, finally, we're at our last function. We need to create another function that'll return a list node, and it'll be called merge sort, and it's going to just take in 2 list nodes. We'll call this left and right. You know what, let's just call these L1, L2, because from all the videos that I've been looking at, it looks like the standard practice is using L1 and L2 for your different nodes. So I'll stay consistent with that. So now that we've got our 2 nodes, what we can do now is we want it to constantly change or update a value of a node while the node has a value. So we'll say that while L1 does not equal null, or L2 does not equal null. And now the reason we're using or is because we don't want to miss an opportunity where 1 is not null and 2 is null, or vice versa. So as long as one of them at least is not null, then we can continuously go through here. So let's do that. Now, while either of these could not be null, we'll say now that if if L1 equals null, so if the L1 is null, that means that L2 is not null. So what we can do now is we need to do some sort of update to a list node. So I'll create a list node up here, and that'll just be our answer node. And this will just be a new list node. This is going to be what we use as our dummy. And what I'll do is that I'll also create another list node that we'll use as our current list node. This is what we're going to use as our kind of like our dummy 2. We're going to be using this one to move around, but we're going to be returning our answer. So this one is just going to be our answer. So now what we could say is if L1 is null, that means that L2 must not be null. So what we'll do now is we'll say that our current.next is going to be L2. Then we move L2 to the next value. Otherwise, if L2 is null, that's just the other side. So that means that our current.next, so the next value is just going to be L1. Then we move L1 forward. Now, we're at this point where both are most likely not null, meaning both of them have values. So now, in this case, what we'll do is we'll check the values. So we'll say if L1.val is less than L2.val, then so that just says that the value here is smaller, so we would want to use that value. So we'll just say current.next is going to be L1. And then we move L1 up. And then lastly, our last case is really just the opposite of this one here, which is basically L2 is smaller than L1. So then we'll just do current.next equals L2, and then move L2 forward. Now, what we want to do at the very end, if all of these or a few of these or whatever amount of these has tripped, we want to then move our current forward. And the reason we're moving our current forward is because we're going through all of these values, and we'll say if, and then otherwise, if none of these ifs have tripped, then okay, it's going to be this here. So now we want to move on to our next value and then iterate through again. Now once we're out of our while loop, and since we restored answer at current, we'll just say to return answer.next. And the reason we're doing next is because we don't necessarily have a value initialized to the top. We're at the root node, so we'll just return whatever the next value is. So it looks like we're good to go here. Let me just run this. L2.next is not a... Oh, so one thing I forgot is we need to, yes, push these forward, but we need to set them. So this isn't really a void. This is more of like you're setting something to another value. So these need to be recalled. So L1 needs to equal L1.next, L2 needs to equal L2.next. Okay, and the same thing here. Current equals current.next. Okay, bad operand, so let's go over here. Line 16, if a list equals null or list.length equals 0. Okay, this was accepted. Okay, so this is the final thing I wanted to mention here, and it looks like there's a Stack Overflow on line 29 and it continuously goes down. And if you go to line 29, we'll see that the issue starts here. So this issue most definitely is occurring due to this line here, because mid might have some value that overflows when doing division. So this is something I just learned, and frankly, I'm not sure why it works, but I know it does. So you'll just subtract start from end and then add start back to it. And that should do it. Anyways, guys, that's it for this one. If you have any questions, comments, feedback for me, or if I didn't make anything clear, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.